About a year ago, I fitted a kind of light to the back of my bed, and this is let's turn on here. It kind of fades up. It's just an LED strip mounted along the back of the kind of headrest, or bit of a headrest that's on here. So it was a really kind of basic project, just a couple of IKEA LED strips connected up to an Arduino, which then, when you kind of triggered it, using kind of pulse width modulation, brought up the brightness to maximum, just left it there, and again dropping down. At the time I didn't have any switches to hand, so the best thing I had that would allow me to kind of toggle it on and off in a semi-decent way was a kind of an IR distance sensor, and so I've just set that up as a toggle switch. So all you need to do is just pass your hand over this end and it brings it up and down. And it turned out to be a fantastic kind of method of switching, but at the moment I'm coming up with, I'm trying to fit a replacement for this. It works really well, but there's a few improvements I'd like to make. I've been using the Neopixel strips recently, and I thought that maybe I could kind of combine the two into a slightly better or more interesting project, something that could kind of turn itself off during the day if there's nobody around, and then even automatically bring the light up in the morning, and as before the alarm kicks in, the light could kind of start to fade up early on in the morning, and to kind of hopefully try and kind of wake me up a little bit better. There is a little bit of research around which suggests that kind of it gets the brain in the right kind of frame of mind. It's a more natural kind of wake-up approach. And so that's something I want to play with as well. And if I switch out this single kind of white strip for a Neopixel strip, then it gives you a lot more flexibility in terms of the colouring and the brightness control as well. And so that's the project I'm working on at the moment. I'm kind of halfway through the build of this, got the prototype up and running. I'm just running a few checks to see whether the LED strip I've got is good enough. So if I toggle that on now, turn off the other light, so it's a much kind of whiter, slightly blue colour at the moment. It's this is running with it's quite a broad spacing for the Neopixel strips. You can get 3 densities of the strips, how kind of far apart the spacing is for the LEDs. This is the kind of broadest one, and my concern is that it's not going to give off enough light. So I'm going to do a few checks today and just see if this strip is good enough, or if I need to get a slightly high density strip. This is the circuit I'm using for this new project. It consists of a Teensy 3.1 on here. The reason for this choice device was mainly I've never used one of these in a proper project before, so I wanted to try something new. And I was also after a clock mechanism in here. And if I wanted it to turn on automatically in the mornings, it needs to keep track of time. And there's adding external kind of real-time clocks are pretty straightforward, but this one has an embedded clock, so that's what the button cell battery is doing here. It's maintaining the time on that. There are some comments about the onboard clock not being hugely accurate, but I think for my use it's good enough, and time will tell if it starts to drift too much. And if it does, it's not a huge task to kind of plug in a laptop and just set the correct time again. I've got, and this is just kind of straight onto a bit of Veroboard. I've got a couple of connectors on here for kind of the LED output light, a switch input, and hopefully a PIR input to detect activity or movement, then drop accordingly. And I've got just an onboard toggle switch just for testing things at the moment. So I've tried out the light overnight, and I'm still a little unsure what the best solution is. My concern at the moment is the density of the light and how much light output it kind of gives off. I mean, it might kind of look interesting, but it still needs to give off enough light to be of use. And the problem, I think it matches the other original light fairly well, I think, if they're both turned on full. But the benefit of having an RGB light is I can set it to a particular colour. I could have it kind of like an orangey light output kind of late evening. But by doing that, I'm severely reducing the light output. So obviously a lot of blue lights aren't going to be on for that. And that means the brightness is going to be less. And so to counteract that, I'd ideally have a higher light density, which would then allow me to output the same brightness but at varying colours. And so it's presenting a few issues. I think I'm going to take the kind of pragmatic approach here and use the light strip I've got. So rather than buying a high density strip, I'll stick with what I have. I've got 5 meters of it after all. And the question I'm toying around with now is, do I double back? So run the length all the way along and then loop it back again. As that would then double up on the density, it would still be controlled in the same way, and for just a static colour, that would work well, I think. I was hoping to make use of this, the fact that each light is controllable individually, to do the odd kind of silly effect, and that kind of does present problems as well, because if you're having a light kind of chasing all the way along, then all of a sudden you're going to have some going back in the other direction as you go, and it'll spoil the effect. The other effect I quite liked was this one. So if I toggle the mode, you've got a kind of a light sequence kind of RGB here, and that is really quite a beautiful light to have. But the problem is, if you double back, then it's not going to be the full length. I guess I could kind of programmatically get around that, but it does then present further problems. So I'm going to toy with the idea for a little bit longer and see what kind of solution I go for. Just had an idea for a solution for this. They're kind of 45 LEDs from one end to the other, and I can double it back and have 90 LEDs in total. And then do that normally for the modes where it's just displaying a static colour. And then when it kind of switches into kind of special mode, I can drop that down to 45 LEDs and just use a single strip. And so half of them will be off, but for effects like this, it's I think easily good enough. I've spent a bit of time today designing brackets to hold the light to the back of the bed, and I think I've come up with a design that works. Now I take a slightly long-winded approach to kind of designing kind of plastic parts like this, but it's an approach I like. You can spend quite a while kind of have a think about what shape it needs to be, design it on the computer and kind of really lay it out. I kind of like to see results kind of pretty quickly, so I start with the bare minimum and just iterate from there. And so this is the first kind of part I came up with. I wanted the light to kind of shine up at an angle slightly, so rather than being flat on the back. And so that's why I've got this slope here, so it would attach like that, and then that would rest against it there, shining up and against the wall. And so I've got a little screw hole in here, which is great. I put a little bit of a lip on there to try and catch the thing, which kind of works but not that well. And so I then added another lip here. So this on here, it sits a lot nicer. You can see there, it really kind of fits in properly, and that would work really well. The problem is it's going to fall off, and so the initial thought was possibly a dab of glue, maybe a bit of kind of a sticky pad or something in there. But I kind of went and tried a different approach. I was printing these on the surface kind of going up, and it's a layer at a time, and so you can't do an overhang that way. And so I had a go and printed it sideways, and so this is the one that's printed this way up, so it printed it a layer at a time like that. And sometimes that isn't so good when you've got a small area on the top here, and also the whole starts collapsed in on a little bit, but in this case it worked really well, which that allowed me to then try this kind of overhang here. And so this is the next version up, and this works really well. It kind of grips in nicely. I was going to fit it on these kind of half points here, and that would work fantastically. But because of a recent decision, I'm having 2 strips of this running across. So originally I thought, okay, I'll just keep it simple, let's just go for 2 of these and attach them kind of next to each other or offset, one above the other. But there isn't enough space, that's too big to sit like that, and going that way it'll kind of knock into each other. So I kind of came to the conclusion, let's put 2 next to each other. So this one here is just slightly elongated. I've had to reduce the amount of angle on here, but it works really well. That then fits in like so, holding two of them in. It doesn't hold it in particularly well, the second strip along, so the next version here had a much larger kind of overhang. It's despite that and despite the kind of narrow ridge here, it is still really tough. And so that feeds on like so, and that can then come back around again and feed in there, and there's enough of an overhang to really kind of grip them nicely. Got a little screw hole, so that'll screw to the back of the bed, and there we go. Got perfect little brackets for this. And so this is something I kind of did during the afternoon. Each one of something like this will take about 15 minutes to print, so going from like 5-10 minutes up to full 20 minutes for one of these. And so it took a little while, kind of print one, do something else, and then when it's done, tweak the design slightly. So it's one of those kind of slightly longer processes, but it really does suit me, this way of doing things. And I've now got these brackets here. These two are the same, and I think the printer has just finished printing another 4. Probably need a few more, so I might start it again doing another run. And the other 3D printed part was the box. This is it's just really meant to provide some kind of protection in case something falls on it or knocks it. So all it is a really straightforward little box here with a kind of centre void, and cut out some connections and a couple of lugs on here for screws. And that is kind of that. This sits in here. It could be a little bit tighter, but it doesn't really matter too much. I'm probably going to attach the board to the box using Blue Tack or sticky pads. It's slightly crude. It would be nice if I could have had some kind of either mechanism in here, but it's the simplest, most practical approach, I think, for doing this. And so that then things connectors on the bottom there. So that should be ideal for that. I've also got decided to print a lid. This is kind of a secondary thought, but I've done kind of a lid or kind of locking parts like this before, and if you use a friction fit, they're really easy to do, and it's very satisfying to kind of get that done. The printer I've got isn't quite perfect, so if you print something, say 10mm across, it'll be roughly 10.5mm. It's where the plastic layers ooze out very slightly. And so when it comes to making something like this, this I think here was I think it's 9cm across with 2mm wall. And so all I do is just a 9cm across panel here, and these blocks inset by 2mm each. And that's really straightforward. I know it's going to push out very slightly, which gives me that friction fit. Goes in there, perfectly there. I've chamfered off the corners on edges on here. This is just so that there's there's nothing to catch really. You can see as it goes in there, it'll just kind of guide itself in nicer. The one mistake I did make with this, whilst only 2 sides are enough to lock this in, at least what I need, it does mean it can do that. So I should have put a little something else there and probably something else along the front just to stop that. But that is good enough. The other change for me this time around, this is the first time I printed onto Captain tape. I normally print on the blue kind of painter's masking tape, which is a fantastic surface. After really having trouble with the kind of mirror, the kind of a mirror bed and the original PCB, the blue painter's tape was remarkable. I mean, it sticks incredibly well. It doesn't kind of move at all. The only problem is it does stick slightly too well, and the tape is almost always destroyed, kind of getting the printed item off. It also leaves, I quite like the finish. I'm not sure if it'll come out here, but it's a slightly kind of rough surface, because it's the painter's tape is slightly furry, it's like a masking tape. That's never really been a problem for me. But I gave Captain Tape a go after some recommendations, and the surface is ridiculously shiny. I really wasn't expecting that at all. It's quite bizarre. The tape, I haven't levelled it particularly well, so there's the odd bubble, which does show as an imperfection in here. There's also the ridge where 2 strips of tape were overlaid. But yeah, it's really remarkably different, this shiny tape, To be honest, I'm not that keen on it. I do prefer the other kind of more matte finish, I guess it would get, but certainly is an interesting kind of change, that. So I think that, along with the brackets, they're all the 3D printed parts of this project. It's a bit dark, but there is a reason for that. During the testing of this, I've been using these lithium-ion battery packs. I've got a couple for quadricopter projects, and this is the kind of best source of kind of a high power 5-volt signal I've got at the moment. I've got a decent power supply on order, but for the time being I'm using these, along with a little switching regulator here. This cable a couple of amps. And what I've noticed, when the battery level starts to drop, obviously the light kind of changes. The blue seems to be most sensitive to colour, which is why it's a lot redder than the light should be at the moment. But the battery packs themselves, I'm not sure if it's an issue with them kind of reaching the end of their lifespan, but it's slightly swollen, and if you squeeze it, you can see what happens. I'm going to hold up the regulator here. You can just about see the blue LED, or maybe on there, and the light point. I'm going to squeeze this pack now. There you go, the voltage has jumped back up. So there's, I'd seen a video before where people looked at the effect on regular batteries. If you kind of squeeze them, compress them, the voltage will change, but typically only by a tiny amount. And this is a huge kind of difference. Just squeezing on this pack is having an effect on the chemical reaction that's going on inside and increasing the output voltage. Whether it's healthy or not, who knows. It's a week later for this project, and in that time I've sourced all the parts I need. I've made a few design decisions and a few changes, and so should be ready to kind of get that all fitted and up and running today. So the main circuit board has changed slightly. I've added a few more connectors on here, and so originally there was just going to be the light output and the switch input. I've added another connector on here for PIR sensor, and I've also added a kind of final connector here. This is for a secondary light strip. And I found during testing that the light, whilst interesting, it goes nowhere near kind of wakes me up in the morning, so I might be able to add a kind of a secondary, more intense light to it, and that's for that if I want to add that in. Because the new connector on here, the box design of the output has changed slightly, so I've got the new kind of layout here. I've reduced the dimensions in very slightly, so it's a slightly better fitting box. Obviously then got openings for these connectors on here. The lid, I've added a kind of final lug at the top to stop it sliding around. The only problem is now, because of the large capacitor that sticks up, that kind of side connection there doesn't fit down, so I'm going to need to reposition the capacitor slightly, but that is that board sorted. In addition to that, what's turned up during the week is the power supply. I've got this really cute little power supply here. This is a 3 amp 5 volt output, and it's I think it's about 20 odd pounds, but it's for this type of project it's fantastic. It's just a really nice little isolated or safe little transformer. It takes just mains input and gives me 5 volts on the output, and this is perfect. The mounting holes for this were kind of a pair of 3mm threaded inserts either on the side of the box or on the base, and so what I've done is just printed out a really basic little plate here, and then so that kind of screws through from the base, and then this can then screw to the surface. So that's pretty straightforward. The other part I've printed out is the panel for the PCB, or sorry, for the PIR sensor. And so this is this will kind of sit on the side, and so what I've got is this piece here. So this clips in there like so. I've got a kind of recessed piece there for the cable that comes out on the front, and that is designed to kind of attach to the back of a panel like that, so it'll attach to the back of one of the struts on the bed and poke over the top. And so it doesn't really need to be enclosed much because it's going to be hidden out the way. This is just to secure it and make it look nice. I'd originally printed this in this kind of crappy blue when I was testing, but I've now put in the kind of clear plastic or semi-clear plastic to get the kind of a more blended approach with this dome here. But with only a couple of layers for this first surface, you really see the honeycomb inside pattern. So I reprinted that the other day, with 5 kind of solid layers to start with, and that's almost completely gotten rid of that. So that's a nice little change. And on top of that, I've got the brackets to hold the light in place, and I believe that is going to be it. So I'm now going to take a quick glance at the existing circuit on the bed and then get that stripped off. So this is the original light I've got back here. It's just a single kind of strip running along, just a white LED strip. And that runs along and feeds down into the mess of electronics down below. Now this, you cannot see any of this from the front, so I was really pleased with this, but obviously it does kind of hide a lot of sins back here. And so there are 2 kind of lighting sets here. There's the little kind of light there, which is connected to this switch here, and the rest kind of carries on down. So there's 2 wires running down here, the power for the light and the kind of contact switch. And then that switch down there is just for this setup here, but all the electronics is inside this box down here. Now this is something I haven't opened for quite some time. And take a quick look. This is when you're kind of building something, you've got to package it into something, and this is all I had to hand at the time. So this is the original circuit. It's just a kind of a full Arduino board underneath, along with a kind of a test kind of shield on the top, and the chip in the middle of that is just a little H-bridge circuit, and so that's all I'm using here. I spent this afternoon playing around with this project, and it's presented a few kind of problems on the way, but I've got most of it up and running now, which is quite pleased about. I'm just about to tidy up some of the wiring and put the final bits away. The board at the moment is still kind of down here. Hook that. So that's kind of just hooked up the 3 sensor inputs there. The PIR sensor is mounted on the side here, and the LED strip you can just see poking over the top along the back. And I'll put the camera around the back in a minute and show how I've hooked it up. The PIR sensor has presented some kind of pretty annoying problems. It's rated at 5 to 12 volts, but it doesn't work at 5 volts, at least not properly, because it requires a 3 volt supply. So it needs a 5 volt internal supply to run, and it's got an onboard regulator, so if you feed 5 volts in, you're going to lose a volt or so on the drop. And so I've had to remove the onboard regulator, bypass that, and that's allowed me to kind of run this successfully from 5 volts now. It's also presenting some problems in that whenever the light fades up and down, it triggers the sensor. So if it goes into, if it's going to kind of turn the light down as it's not detected anything, the light fading out triggers the sensor, which then resets the whole process, meaning it's kind of useless. So that's something I will have to look into and see if I can find a fix for. Around the back I've got the power supply unit here. This is just strapped to the top. Unfortunately, when it sits back against the wall, there's no room to put anything on this bit here, so it's been raised up very slightly. But that's not too bad, and that's running. It's not particularly, slightly warm on the side, but it's fairly safe. I've just chopped off an old IC cable to power that. The main electronics box is fitted over here. I'm not too pleased about this location, but given that I can't mount it down here, it's, I think, the best option available to me, sadly. The cabling then runs up behind here, kind of completely invisible from the front. And you've got the rear of the PIR sensor, the sensor to detect activity, and obviously the light strip running along. You see that's it kind of switching down there. You saw it kind of dulled out for a moment. That's the inactive mode, but as I was saying, the light then triggered it to come back on again. Everything's now back. It certainly didn't all go to plan. The PIR sensor is now disabled, and I'll probably revisit that at a later date. But one of the kind of core points for this was the kind of automation and the kind of light changing, which is in place. This light will turn on automatically in the morning, and it will also change colour depending on the time of the day. And so it's kind of almost 9 o'clock in the evening, and that's the changeover point. So hopefully kind of catch that in a minute. Otherwise, it's it's fairly successful. I think there's problems, but I'm certainly pleased. The kind of worry was that I'd end up with a situation where it wasn't working at all, and I'd be worse off than before I started, but that's not the case. It is certainly an improvement over the previous project, so I'm happy.